Hello friends, today we are going to discuss about the angle between the two polar curves. Sometimes we may say angle of intersection between the two polar curves. As already we discussed, what is the equation we are using for angle between the radius vector and the tangent, that is tan of phi is equal to r into d theta by dr. So here we will extend the same thing for the two curves. So the angle between the two polar curves we have, so here we are considering the two polar curves, that is two curves r is equal to f of theta and r is equal to g of theta. Let us the tangent to the curves makes an angle phi 1 and phi 2 with the initial line respectively. So here we have the diagram of that. We considered OL is the initial line and OP is the radius vector. So we have considered here two curves, the one curve making an angle phi 1 with the tangent T1 and the second curve making an angle phi 2 with the tangent T2. So the angle between these two curves, that is phi 1 and phi 2, angle between phi 1 and phi 2, here we have the equation angle between the curves is equal to modulus of phi 1 minus phi 2. So we have to identify for the first curve the angle between the radius vector and the tangent, that parameter we are using as phi 1, and similarly the second curve r is equal to g of theta, we have to find the angle between the radius vector and the tangent, that is phi. For the second curve we are calling as phi 2. So if we'll take difference of these two with the modulus, we'll come to know what is the angle between the curves. So here we have orthogonal curves also. So what is the condition to say that the given curves are orthogonal to each other, that we'll consider now. So here the two curves are said to be orthogonal if modulus of phi 1 minus phi 2 is equal to pi by 2, or tan of phi 1 into tan of phi 2 is equal to minus 1. If this condition is satisfied, then we can say the given curves are orthogonal to each other. That is modulus of phi 1 minus phi 2 is equal to pi by 2, or tan of phi 1 into tan of phi 2 is equal to minus 1. Either one condition satisfied, then the given curves are said to be orthogonal each other. So now we will consider one simple example how to apply this angle between the two polar curves, how to identify the modulus of phi 1 minus phi 2. Let us consider now. So here we have the example. Find the angle between the two curves r is equal to a into 1 minus cos theta and r is equal to 2a into cos theta. So here they have given the two curves. So let us consider the first curve as the equation 1 and the second curve as equation 2. We have to do separately for finding the angle between the radius vector and the tangent. So here r is equal to a into 1 minus cos theta is the equation 1, and similarly second equation r is equal to 2a into cos theta, that we are calling as equation 2. So now what we'll do, we'll differentiate the equation 1 and 2 with respect to theta. Differentiate equations 1 and 2 with respect to theta. What we'll get here? Dr by d theta, and here also dr by d theta. So that we'll have now. So the first equation, just to observe, dr by d theta is equal to a into derivative of 1 is 0 and the derivative of cos theta is minus into minus plus sine theta. So we'll have here dr by d theta is equal to a into sine theta. So what is the second equation? Dr by d theta is equal to, do differentiate cos theta. So we'll get minus 2a into sine theta. So therefore, after getting dr by d theta on the both the equations, now we'll consider the angle between the radius vector and the tangent. Angle between the radius vector and the tangent, the equation here we have tan phi is equal to r divided by dr by d theta. So what is the r? We have to take the both the equations, r as well as dr by d theta for the first curve, and similarly r dr by d theta for the second curve. So for the first curve, we have the r as a into 1 minus cos theta and divided by a into sine theta. Similarly for the second curve, 2a cos theta divided by minus 2a into sine theta, that we have here, just to observe now. So for the first curve, we are calling as tan phi 1, which is equal to a into 1 minus cos theta by a into sine theta. Similarly, tan of phi 2 is equal to 2a cos theta by minus 2a into sine theta. Just to observe here, a get cancelled, and here also 2a get cancelled. So now tan phi 1 will get it as 1 minus cos theta by sine theta, and tan phi 2 will get it as minus cos theta by sine theta, that is minus cot theta. So here we have to convert the RHS part in terms of tan only, so that we can get it the value of phi 1. So that you can observe here, phi 1 is equal to, here 1 minus cos theta we can rewrite as 2 sine square theta by 2, and here sine of theta We know the formula for sine 2 theta, that is 2 sine theta by theta into cos theta. But if we'll take for sine theta, means theta is equal to theta by 2, the equation will be 2 sine theta by 2 into cos theta by 2. Second curve, tan phi 2 is equal to cos by sine is minus cot. So now here 2 get cancelled, one sine term get cancelled, it retain as only sine by cos. You know sine by cos is tan. So tan phi 1 is equal to tan theta by 2. We'll get what is the phi 1 easily. But here if you'll observe for the second equation, here we have minus cot theta. Using the ratios of the allied angle, we can convert minus cot theta as tan of 90 plus theta. That is tan of pi by 2 plus theta. So therefore, tan of phi 1 is equal to tan theta by 2. Second curve, tan of phi 2 is equal to tan of pi by 2 plus theta. So that tan everywhere get cancelled. For the first phi 1, we'll get it as theta by 2. And the second curve phi 2 is we'll getting as pi by 2 plus theta. As we know angle between the two curves, right? Modulus of phi 1 minus phi 2. So we'll substitute in the place of phi 1 as theta by 2 and phi 2 as pi by 2 plus theta. So here we have angle between the two curves as modulus of phi 1 minus phi 2. So therefore, the angle between the curves is phi 1 minus phi 2, that is phi 1 is theta by 2 minus phi 2 is pi by 2 plus theta. So therefore, pi by 2 minus theta is minus theta by 2. So minus pi by 2 minus theta by 2. If we'll take negative sign outside, we'll get it as pi by 2 plus theta by 2. So therefore, yeah, angle between the two curves should not be in the theta form. It should be either in the radian or in terms of pi. So how to eliminate this pi? We have to find out this theta by using the given curve. So what they have given, angle of point of intersection is r is equal to a into 1 minus cos theta, and the second curve r is equal to 2a cos theta. You can see the LHS are same. We can make the RHS term is also equal. So therefore, a is equal to 1 minus cos theta is equal to 2a into cos theta. Here you can observe a get cancelled. We'll have 1 minus cos theta is equal to 2 into cos theta. If we shift this cos theta to the RHS, we'll get 1 is equal to 3 cos theta. So here we have 3 cos theta is equal to 1. So therefore, cos theta is equal to 1 by 3. So therefore, theta is equal to cos inverse of 1 by 3. So this we have to substitute in the angle between the two curves. That is pi by 2 plus theta by 2 here we have. So what is the value of theta I got? Cos inverse of 1 by 3. Therefore, the angle between the given curves will be pi by 2 plus 1 by 2 into cos inverse of 1 by 3. Thank you.